again, we'll have your,
Okay na po.
we'll have your quiz 3 next week on Tuesday. Written. So we'll be finishing everything by Saturday this week. Then your quiz 4 will be on Thursday next week. So it's up to you, dahil online naman yon, pwedeng Thursday, Friday, or Saturday. Kung gusto nyo, linggo pa, pwede rin. So perhaps, mag-voting tayo sa online through chat. And then your final exam will be on Tuesday next week. So mas maganda ata piliin nyo Thursday or Friday yung quiz 4 para you have time, di ba, to study for your finals. Okay. Now we're going to be having another topic which is about entropy, enthalpy, Gibbs free energy, and its or their relationship with the spontaneity of reactions or processes. Saan yung unang narinig yung spontaneous process? Sa second law, right? Sabi sa second law, all real processes occur spontaneously. Diba? Nangyayari na kusa. Diba? In the direction of what? In the direction that increases the entropy. Okay, so if we might recall, doon sa second law, ito yung, nakikita ba, Mr. Rodrigo?
Yes, sir.
Yung nasa TV.
Yes, sir.
So
Dito.
again, if you may recall, all real processes occur spontaneously in what? In the direction that increases the entropy of the universe. Last time, what we have considered are some examples that show us what? Spontaneous reactions, right? And I think the most simple example that we had was what? Naalala niyo pa yung ice melting in your palm, di ba? Melting of ice is what? A spontaneous process. Kasi kahit wala kang gawin doon, hayaan mo lang yung ice, matutunaw at matutunaw yun, right? And again, as you may see, ano nangyayari dun sa entropy ng system, which is the ice? What happened to the entropy or disorder of the system? What happened? It decreased, tama ba? Kasi from solid, may order, naging liquid. Mas disordered yun, tama ba ako? So if we're gonna be taking the delta S, because the symbol for entropy is what? S. So if I have to account for the delta S, change in ano yun? In entropy. Ibig sabihin, S final minus S initial. So ano yung magiging delta S ng ice? Positive or negative? Positive, kasi nag-increase, right? Now, what about the surrounding? Ano yung surrounding natin? The palm is the surrounding. So if I'm going to be accounting for the delta S naman ng palm, ano yung delta S niya? Positive or negative? Well, at least for now, we can say na negative yun, right? Kasi siya yung nag-transfer ng ng heat doon sa ice. Tandaan niyo ito lagi. Kapag yung part ng universe ang nag-accept ng heat, laging positive yung delta S mo. Understood? Pero yung part ng universe na nag-release ng heat, hindi pa laging negative yung delta S. Okay? So later on we'll have some other examples of spontaneous reactions for you to understand that. But for now, I think it's easy naman, no, to grasp that whenever there is a part of the universe that receives the heat, ano yung delta S nun? Positive. Tataas yung entropy nun. Yung nagbibigay ng heat, again, for now, we can accept na negative yung delta S. Perhaps we can say, yung palm mo kasi, mas bumaba yung temperature, di ba? Nung nag-release ng heat or nag-transfer ng heat doon sa ice. And because of the decrease in temperature, di ba? Ano nangyari sa entropy ng palm? Bumaba. You understand? Now listen. Take a look at again the second law statement. It says here that the increase in entropy is the increase in entropy of what? Of the universe. So there is a revelation here. Kasi last time, we're just accounting for the entropy of the system. Where in fact, ang sabi sa second law, it should be the universe, not the system lang. Naalala pa yung dropping of an object from here, papunta sa ground? Di ba yung object yung kinukonsider natin na nag-increase yung entropy? But what about the ground? You understand? Another one is yung burning ng gasoline, naalala yan? Oh, again, we just consider the system, which is the gasoline. Nag-increase yung entropy niya. But what about the surroundings? Understood? So it should be again the change in entropy of the universe, not just the system nor the surroundings alone. And so we have a formula for that. Delta S universe accounts what? The delta S of what? Of the system and the delta S of the surroundings. Understood? And again, based on the second law statement, if that is a spontaneous process, ang sabi daw, ano dapat yung delta S universe? Positive or? Ano ibig sabihin ito? Greater than 0. Positive value. Understood? So again, taking again the earlier example, yung melting of ice. Ano yung system natin doon? Yung ice. Positive ba or negative? Yung delta S. Ha? Positive. Ano yung delta S ng pound? Negative. So kung parehas ng magnitude dyan, ano yung delta S universe mo? 0 yan. Dapat, kung delta S universe ay greater than 0 or positive, dapat mas mataas yung delta S mo sa system. Paano natin masasabi na mas mataas yung change ng entropy ng system? Ibig sabihin, mas nag-increase. Okay? Mas malaki yung magnitude ng change is that the positive change is greater than the negative change. Okay? So I'm gonna be jumping a little bit for you to understand why is that. Accept this fact, the one that receives heat is the one that has a higher magnitude of change. Sino yung tumatanggap ng heat? Siya yung part ng universe, whether that be a system or the surrounding. Siya yung merong mataas na magnitude of change. And that change is again what? Kung sino man yung tumatanggap, that's always positive, di ba? Okay? Now let me give you an example. This is a little bit disgusting. Okay? But I think it will help. Kapag meron kayong sipon, halimbawa, you would say na may mataas yung entropy ng ilong mo, di ba? May disorder. Understand? Kasi may sipon. Tama ba? Now, if you get a tissue, a white tissue, okay, and for example, your nose is the system, and the tissue is what? The surrounding. So what are you going to do? Isisinga mo, di ba? Matatransfer yung sipon, papunta dun saan? Sa tissue. Now, ano nangyayari sa entropy ng system, ng ilong? Bumaba. Di ba? Ano nangyayari sa entropy ng tissue? Mataas. Kitang-kita naman. Di ba? Lalo na pag merong doon. Now, if you're going to compare the magnitude of change, yung magnitude ng change ng disorder sa ilong versus dun sa tissue, sino mas mataas sa magnitude? Yung nag-receive, di ba? Yung sipon. Why is that? Because listen, like heat, it is what? It is dispersive. Pag sinabing dispersive, pakalat yan. Whenever there is transfer of heat, ang heat, dispersive yan. Hindi yan parang linear transfer. Nadi-disperse yan. And so it has something to do with volume. Nakita mo, yung una dito, maliit lang yung volume occupied, di ba? But then, nung sininga mo dito, sorry for the example, nung isininga mo na, laki ng volume na na-occupy. You understand? So that's the same as heat. Whenever heat is being transferred, dispersive. Kaya nga later, now we'll see that volume has something to do with what? Entropy also. Kasi mas malaki yung volume, mas mataas ang disorder. Di ba mas acceptable sa inyo kung dito lang ako gumagalaw? What if pabalik-balik ako if I cover that entire body here? Ano mangyayari sa inyo pag ganun-ganun kayo? Di ba? But you notice, but the disorder, mas mataas. Do you understand? And so, if that is true, sino yung tumanggap ng heat doon sa example natin? Yung system or yung surrounding? Sino yung tumanggap? Diba yung ice, which is the system? No, not the simple example. The ice and the what and the palm example. Sino yung system doon? Yung ice. You may not notice, but once the palm transfers the heat, disperses mo. You understand? Kaya ito is more than the magnitude of change doon sa. And so, delta S is what? Universe will be what? Greater than 0 or positive. Naintindihan? Ayos ba? So, we'll have some other examples para mas tawag dito, masanay kayo. Because again, as I've told you, kung sino yung tumanggap ng heat, positive yung change nun. Pero not necessarily yung nag-release ng heat. Sabi ko, di ba, not necessarily negative yung change. Yun yung kailangan natin i-account. Okay? Because other factors affect change in entropy. Okay? So,
Sir, ano yung considered na real processes mo?
Alin?
Real processes, ano yung sinasabi yan na real processes?
Spontaneous processes. Halos lahat naman ng processes ay spontaneous. Diba? Life is a spontaneous process, right? That is spontaneous. Aging is a spontaneous process. Mapipigilan mo ba ang aging? If life is a spontaneous process, then that alone can explain that all processes occurring are spontaneous processes. And again, there are some processes that needs what? A push, diba? For it to proceed. But again, it is still considered as what? As a spontaneous process. Okay? It's kind of, if you're going to be strict about the spontaneity of processes, no? Life is one spontaneous process, okay, with some non-spontaneous and some spontaneous processes. Now, within life, may mga non-spontaneous processes. Okay? But if we're gonna be considering life is a spontaneous process. And so, everything will be what? Part of that spontaneous process. Okay? Any question? Is this a spontaneous process if I get this water and I drink? Spontaneous ba yan? Again, depende doon saan? Sa magiging reference mo. Kung ang reference mo is ito, hindi naman to pwedeng spontaneously magpunta sa akin at mainom ko, di ba? Kailangan ng help, di ba? And that is what? That is a continuous help. So in that case, hindi siya spontaneous, tama? Right? But again, if my reference is life itself, di ba? Kailangan ba nating uminom? Yes. Do you understand? So that's a good question, actually. The practicalities, again, will be depending on your reference point. Right? And again, entropy is what? Affected by other things. Temperature. I think, alam nyo na yung phase change, no? Mas mataas ang entropy ng gas kesa sa liquid, kesa sa solid. Dissolving a solid or liquid, halimbawa, sugar, dinissolve mo sa water. Ang nangyayari sa sugar, tumaas o bumaba yung entropy? Tumaas, di ba? Mas makakagalaw yung molecules mo pag nasa water na siya. Dissolve mo. Dissolving a gas, CO2 for example, or air, then i-dissolve mo dito sa sa liquid. So, ano mangyayari sa entropy ng air? Right. Kuha ka ng straw, kaya CO2, i-bubble mo dito. Di ba, madidissolve yung CO2 dito? Ano mangyayari sa CO2? Tataas ba or bababa yung entropy? Bababa yung entropy. Di ba? Mas nakakagalaw siya saan? Sa CO2 mas nakakagalaw siya sa body mo eh. Kasi hollow yung body mo. Eh pag dinisolve mo na yan sa water, hindi naman hollow yan, di ba? Are you getting that? Ibig sabihin, mas restricted yung movement ng CO2 sa water kaysa sa katawan mo. Mas restricted ang movement, mas mababa yung disorder. So ano yung change in entropy? Negative or positive? Ano ba sabi ko? Negative. Pero yung sugar sa water, ano yun? Positive or negative change? Positive. Kailangan masanay kayo on this because again, you're gonna be having some example reactions. Okay? Okay, so far so good. Okay naman kayo. Ito lang yung examples na tinake natin last time. Good. Again, should have other examples. So usually, the term process is a much more general term. Yung parang sinabi ko kanina, parang life is a process, di ba? Then within a process, there are several reactions occurring. Right? So reaction is a bit more specific process, no? Compared to the term process. Okay? Okay, we'll have examples of exo-N endothermic reactions. I think you already know what exothermic reactions are. These are reactions wherein the system is the one, releasing heat, right? Endo, reactions wherein the system is the one absorbing heat. Okay? So from there, you would already have a delta S sign for the system, di ba? Kung exo yan, sino yung tumatanggap ng, kung sino yung tumatanggap ng heat, positive lagi yon, di ba? Pero hindi porke nag-release ng heat yung part ng universe, negative ka agad siya. Yung delta S. Naalala yan? Ang sure lang tayo is yung tumatanggap ng alin, ng heat. In the case of exothermic reaction, sino yung tumatanggap ng heat? Yung surrounding. Okay? So I should not pertain to the system, rather the surroundings. And again, in that case, delta S ng surrounding is already what? Positive. Kasi exothermic, siya yung tumatanggap ng heat. But what about the system? Ito na tayo. Dito na magkakaroon ng complications. Kasi nga, siya yung nag-release, but that doesn't mean negative yung delta S. Because there are, again, some other factors that need to be considered. First reaction is what? C6H12O6, which is a solid, that is sugar. Yung matakot dyan. Sugar lang yan. And hindi naman kayo magkakabisado ng chemical formulas, no? Binigay yung chemical equations, you just have to analyze. Okay? So sa reactant side, meron ba sugar reacting with what? Oxygen, which is gas, and that will lead to what? To carbon dioxide plus H2O plus heat. Pag kumakain ka ng chocolate, may sugar yon, di ba? Eventually, yung kinain ng chocolate, may sugar doon, mag-react yun doon sa oxygen na ini-inhale mo. Yung reaction na yon ang nagproduce ng alin na CO2. So pag kumain ka ng CO2, ng chocolate, sugar, nagre-react yun dun sa oxygen na ini-inhale mo. Pag nagsalita ka after mong kumain, may CO2. Hindi lang CO2 yung lumalabas na gas, pati ano daw? May H2O vapor dito, or H2O gas. You understand? So hindi lang CO2 ang lumalabas sa akin ngayon. Dahil kumain ako ng nilagang baka. May kanin doon. May sugar yun, di ba? O carbohydrates. May CO2 and then may H2. Hindi lang H2O, meron din kasamang alin? Heat. Understood? So again, the system is what? The sugar. We can see or account for the change in entropy of the system. Kasi alam na natin yung sa surroundings, di ba? Ano yung sa surroundings? Dahil siya yung tumatanggap ng heat. Positive. Nakalagay naman ha. Kita ba, Mr. Padrino?
Yes, sir. Kita po. Sir.
Delta S sa surroundings ay, kita? Greater than 0 or positive. Now again, you may say that the delta S for the system would be what? Negative, di ba? Pero ano nakalagay dito? Greater than 0 din. Positive din. Di ba? So ano yung naging reason kung bakit positive din yun? Kasi ang sabi ko kanina, hindi porke nag-release ng heat yung part ng universe, negative na kaagad yung ano yan, yung delta S. Di ba? So we now be accounting for the change in entropy for the system, which is positive. Why is it positive? There are two factors that affect it. Una, yung phase. Pangalawa, yung dami ng particles. Pag hindi mo nakuha sa phase, punta ka sa number of particles or moles. Okay? So doon sa reaction natin, left side yung alin, reactant, di ba? Ano yung right side? Product. Yun yung titignan mo. Anong nangyari after the process? From reactant to product. Sa reactant, tingnan mo yung mga phases. Ano yun? Solid tsaka gas. Initial state yun, right? After the process, ano yung meron tayo? Puro gas. So from solid, di ba? May solid ka dun sa una. Pagdating mo sa pangalawa, sa product, puro gas na siya. Ano ibig sabihin nun? Ano yung entropy change ng system? Ito yung buong system mo ha, ito. Yung reactant yung initial state. Product yung final state. Titignan mo lang sa reactant yung phase at sa product yung phase. Kuha? And again, that is what? From solid to gas. What is the delta S? Now, there are cases na puro gas. Halimbawa, puro gas yung reactant, then puro gas din yung alin, yung product. Hindi mo pwedeng i-account yung phase change, di ba? Ano yung pwede namang i-account? Number of particles. Saan nakikita yon? Pagka ganito, di ba, 1 yan? Ito ilan to? 6. O, dun sa kabila, ilan? 12. So, either of the two, whether phase change or number of particles, delta S ng system ay ano? Positive or negative? Positive. Kaunti, dumami. Anong mas magulo? Yung kaunti o yung mas madami? Yung mas madami. So final entropy is what? Higher. O delta S is what? Positive. Hindi naman mahirap, di ba? Basta ang sure is what? Kung sino yung tumatanggap ng alena ng heat, yun yung may positive change. Pero yung nag-release or nagbibigay ng heat, hindi pa laging negative. Right? Understood? So kung parehas na positive yun, yung delta S universe natin. Positive din. Hindi mo na kailangan sabihin na yung nag-receive ng heat ay greater yung change. Tama ba? Which is true. Hindi mo na kailangan sabihin yun kasi parehas namang positive. Kailan lang ina-apply ito? Kapag magkaiba ng signs. Follow? Tingnan natin yung pangalawa, baka magkaiba yung sign. Okay? Calcium oxide, which is solid, mag-react sa CO2, which is gas. Ano yung magiging product? Calcium carbonate, which is a solid, plus heat. And again, delta S universe is what? Positive. Now what about the system? O, tingnan natin, from solid gas to solid. Sa phase change pa lang, nakita na natin na that is what? From gas to solid. Yung na i-account to, di ba? So from gas to solid, ano yung delta S mo? Negative. O bakit negative? Kasi nung una, meron kang gas. Nung pangalawa, puro solid ka na lang. Sino mas mataas ang disorder? Yung gas o yung solid? Yung gas. Kaya yung disorder mo, bumaba kasi naging solid na lang. Tama ba ako? Kaya ang delta S mo is what again? Negative. Practice yan. Hindi yan makukuha kagad. Pero practice.
So, paano pag solid gas as solid gas yun?
Yung nga, you have to account for the number of particles.
Yun.
Tama. Pero kung sa phase change pa lang, nakita mo na kung ano yung sign ng delta S, hindi mo na kailangan pumunta pa sa number of particles. Kasi magiging same lang yun. Tingnan natin, ha? Number of particles, ilan dito? 1. 1. Ilan dito? 1. Bumaba. Delta S is still negative.
Sir, may chance na solid gas tapos maging product liquid.
Pwede.
Kung may ganun sa, ano ba yun? Pwede pa
O, paano yun? Solid gas, tapos liquid. Di ba meron kang gas doon sa una? Mas mataas ang ano nun, ang entropy nun eh. Kaysa sa liquid. O ano yung delta S mo? Negative.
Kahit sir may solid
Yeah.
gas.
That's a good point. Kuha?
Solid gas tapos liquid.
Plus liquid. O ano yung delta S nun? In terms of phase change. Dahil may gas ka, sa una, mas mataas ang entropy nun, di ba? So ang delta S mo is what? Now, dito na yung complication kasi yung isa positive, yung isa negative. Doon mo na i-apply yung fact na kung sino yung tumatanggap ng heat, mas mataas yung magnitude of change. Kaya tingnan mo, power greater than 0 to. Ibig sabihin, mas lamang to kaysa saan? Kaysa dito. Kaya ang delta S universe mo ay still positive. Sige. Magtanong ha, Mr. Ardonia. Nakuha? Ano ibig sabihin nito? Ang ibig sabihin nito is double positive.
Galing yan sir sa surrounding.
Yung surrounding siya kasi exothermic eh. Pag exothermic, siya yung tumatanggap ng heat. So expect mo, ang surroundings, delta S nun lagi ay positive. Diba? Kasi exothermic. Mamaya pag endothermic na to, ano naman yung positive ng delta S? Yung system naman, di ba? Nakuha?
Always one.
Ha?
Always one.
Kapag exothermic, yung sa surroundings. Pero yung system, you have to, account for the phase change and number of particles. Now listen. Sinabi na rito na ano siya, lahat to ay spontaneous reactions. Sa exam, bibigyan kayo ng reaction doon, hindi sasabihin kung ano, kung spontaneous o hindi. Kuha? Ngayon, ito yung complication. Mahirap gamitin yung delta S universe criterion. Kaya nga, sa makikita nyo dun sa title, no? Merong enthalpy, entropy, and Gibbs free energy. Yun yung criterion na gagamitin mo para malaman, no, kung spontaneous ang process o reaction na ibinigay. Ano yan eh? Step by step muna tayo. Kasi mahirap gamitin yung delta S universe, tama ba? Mahirap gamitin yung delta S universe. Bakit mahirap gamitin si delta S universe? Ha? Bakit mahirap gamitin si delta S universe? Listen. Ina-apply natin to, listen, yung fact na mas mataas yung magnitude nito kasi alam na natin na yung reaction ay spontaneous. Ibig sabihin, kailangan may lumamang, di ba? Okay? So anyway, we have two criteria, or two criterion to be used. The first criterion is the delta S universe, and the second criterion is the delta G of the system. Okay? Doon na papasok yung entropy, yung enthalpy, doon sa time. For now, any question from here? Madali lang. Mr. Rodrigo.
Sir, bakit yung double plus dun nasa system, tas yung dun sa number 2, ma'am, sir?
Ang
Nasa
example
surround.
natin dito is what? Melting of ice.
Depende, sir, sa example. Sa
Ang melting of ice is not what? Exothermic. Endothermic to. Yung ice na nag-absorb ng heat. Diba?
Yes, sir.
So anong ginawa dyan sir?
Dito kasi, ang ina-account natin na change, no? Or factors that affect the change in entropy ay yung number of particles tsaka phase change. Dito, ang ina-account natin dito is yung temperature. Temperature. Di ba yung surroundings, which is the pump, bumaba yung temperature na di ba? But then again, hindi lang temperature yung nakaka-apekto, di ba? Sabi kanina dun sa entropy, it affects phase change, and other stuff. Do you follow? Sige, you try to absorb that. Buti na itatanong mo yan, sir, kasi mas na-enlighten. Hindi ko kasi sasama all at once. So, others will be arising from your questions.
So sir, dito yung ginawa doon ay ang mga change in that
Hindi.
Sir, anong process yung ginawa po dyan? Sa CEO pati
Alin?
sa maging calcium carbonate? Parang pinainit po. Anong process yung ginawa po dyan sa maging calcium carbonate?
May yun, reaction yun. Halimbawa, meron kang calcium carbonate. Calcium oxide, solid. Tapos in-expose mo sa CO2 at a certain temperature. CO2. Okay. So si Ca, yung nasa surface dito, chemistry na to na meron tayong tinatawag na reaction energies. We have to account for that na. Tatagal tayo. So, si Ca dito, makikipag break ng bond kay oxygen. Tapos, makikipag bond kay CO2. Then si CO2 naman, dahil may oxygen ka doon, sasama dun sa oxygen dito. And again, something to do with the reaction energies. Sino yung mas negative, mas pipiliin niya yun, no? Na makipag.
Sir, at room temperature po yan, sir?
Alin?
Nagbaba na lang. At room temperature?
Room temperature ba ito? Hindi siguro. Mga greater than 25 degrees Celsius. Greater than 25. Para mas maging effective. Ano to ang CaO kasi, very reactive na sa CO2. And again, something to do with their reaction energies. Hindi yung kasama dito. Okay? Kaya gusto ko lang maintindihan nyo is what? Yung change ng entropy ng mga parts involved. It's that system.
Sir? Sir, kapag nag-double plus ba, sir, automatic yung kabila negative din, sir?
Alin?
Yung kunwari, sir, yung sa system, sir, nag-plus na yun. Hindi na pwede
That's a good
mag-plus.
question. Dino-double plus natin kasi nakalagay na siya, na spontaneous. Ibig sabihin, dapat mas lamang yung positive. Tama ba? Kaya nga sabi ko sa inyo, kapag pinigyan ka ng reaction at di mo alam kung spontaneous o hindi pwedeng gamitin basta-basta sino? Delta S universe criterion. Nakukuha? Ito kasi alam na natin na spontaneous kaya ina-apply natin na mas lamang yung isa.
So sa mga susunod sir, alamin na natin ito sa container sir.
Yeah, exactly. And in that case, ibang criterion yung gagamitin natin. Not the delta S universe criterion, or the delta S universe equation, rather the delta G system equation, yung Gibbs free energy. Kuha?
So yun yung ano, including din yung mga
Enthalpy, other
other
properties.
Thermodynamic processes, sir. Ay, hindi pala.
Devices?
Devices.
Oo, may mga, ay ganun. May isasama natin yung madami to actually. Pero ito yung pinakamadali kasi nag-enjoy yung mga student dito sa topic na to.
Madali pa pala yun.
Eh di ba sir, yung thermodynamic devices na re-review siya ng entropy, sir?
So mamaya, i-apply natin yun.
Hanggang 5:30 tayo.
Madaming concepts dito. Pero matutuwa kayo kasi lahat may kukonekta dun sa previous topic. Even dun sa very first topic. Okay na tayo? Endothermic naman. Pag endothermic, expect mo, makikita mo kung exothermic or endothermic pag yung heat nasa product, exo yun. Tinan mo yung heat dito, nasa product, di ba? Pero pag ang heat nasa reactant, endothermic. Nakuha ba? Kasi walang nakalagay ito kung exo or endo. Titignan mo lang kung saan naka-place yung heat. Okay? Think about that. Ang daming reactions. Ang dami kong pwedeng ibigay sa inyo.
Sir, why do we need to be displayed in the child exothermic reactions?
Oo.
So yung product yun, ano po yung product?
Ang product is yung right side. Otherwise, stated. Dito ko mag-start. Kung ano yan, reversible. Eh, huwag na yun. Basta ganyan. Endothermic. Tingnan nyo. Melting of ice. First example. Delta S ng system natin is, again, alam na, positive, di ba? Now, what about yung surrounding? Dito, wala tayo nung phase change, di ba? So maybe we can account for the change in temperature. Okay? Now take note. Take note that yung melting of ice mo can be considered an isothermal process. Ibig sabihin, hindi nagbago, pwede mo sabihin na hindi nagbago yung temperature ng ng ice. Diba? Phase change is an isothermal process. Kuha? Kaya nga, kung hindi nagbago yung temperature ng ice, saan mo in-account? Sa phase change. Kuha? Pero yung palm, ano nangyari sa temperature nun? Siyempre, bababa yun. Dahil siya yung nag-supply ng ng temperature doon sa ice. Okay? Number 2. Dissolving of ionic compound. So ano to? NaCl daw, lagay mo saan? Sa H2O. This is solid, this is liquid. Ito yung naging final product, aqueous. Basically, yung NaCl mo, parang sugar lang din to di ba? Nakalas. Wala nakalagay dito, ha? Ito pa. Kapag wala nakalagay na heat dito, wala rin nakalagay na heat dun sa reactant, ibig sabihin nun, endothermic siya. So malalaman mo lang kung exothermic pag merong heat sa product. Pero pag wala nakalagay na heat, consider mo siya as endothermic. Kuha? So endothermic to. Okay, delta S system is what? Positive. What about yung delta S ng surrounding? Ano yung surrounding dito? Nakikita ba? Meron akong H2O. Nilagyan ko ng NaCl. Okay? Nilagyan ko ng NaCl. Ano nangyari dun sa NaCl? Nung nilagay sa H2O, naging Na plus, tsaka Cl negative. Okay? You may not actually know this, but whenever you are dissolving something, merong heat na sinusupply sino? Si surrounding. So this is Q surrounding. Okay. Kaya nga, ang surrounding natin is what? Is less than 0. Para natin nasabi na less than 0? Hindi natin ma-count yung alin, yung phase change saka yung number of particles, di ba? Kasi yung equation natin o reaction para lang kanino? Kay system. Understand? O, nakuha ba yun? Kapag endothermic process, tandaan nyo to, pag endothermic process, like this, no? These are endothermic processes. Yung surrounding ang nagsusupply na heat. Tama? And in that case, dahil wala kang equation para kay kanino? Kay surrounding. Tama ba? Kasi equations mo palaging kanino? Para kay system. Sige, Miss Soriano, may tanong ka.
Kala ko po sir yung endothermic absorb.
Yeah. Kaya nga yung delta S ng system mo ay positive. Na paano yung kay surroundings? Di ba sa surroundings ang nagbibigay ng heat? How do you account for the change in entropy? Sa phase change ba? Or perhaps sa number of particles? Hindi pwede, right? Bakit? Yung equations na binibigay palagi kay system. Okay? And so the only way to account for the change in entropy of the surroundings is what? Through change in temperature. The fact that they are it's the one that gives the heat. Follow? Parang ito, melting of ice. So, the surrounding, si Pound, di ba? Yung nagbigay ng heat.
So, endothermic reaction, so, release tayo na
Sa surroundings. Kasi si surroundings ang nagbibigay ng heat kapag endothermic. And the fact that it happened, yung temperature ng surroundings, ano mangyayari? Bababa. Tama?
So, negative.
Which again, makes it harder to use the delta S universe criterion. Kasi, medyo inconsistent, di ba? Tama? Para bang nag-a-assume ka lang na ganito, ganyan. Hindi katulad ng isang criterion, talagang mas mas definite. Walang inconsistencies. Why? Later you'll see, kapag delta G na yung gagamitin natin na criterion at delta S universe, system lang yung kailangan mong i-consider. Hindi na yung surroundings. Kuha?
Sir, yung H2O po sir, sa percentage, parang
Ito na, aqueous na siya. Ibig sabihin, NaCl plus H2O na siya. Parang ganito siya. Solid nung una, di ba? Plus what? Plus? Ito ba? Plus H2O liquid, di ba? Naging ano siya? Naging liquid na lang. Kasi ang aqueous ay liquid. So ano nangyari sa entropy change ng system? Positive pa rin. Whether that phase change or because it's the one that absorbs the heat.
Pero yung entropy ng surroundings is negative.
Negative kasi nga,
Siya yung
nag-supply ng heat.
sa system.
Pero kapag exothermic, di ba? Sabi ko kanina, hindi porke system yung nag-susupply ng heat, negative na yung change sa entropy. Owa? Kasi we had accounted for what? The phase change yan.
Yung system sa yung
Oo, ito mismo. Tapos nilagay mo sa... Itong buong equation na to, yun yung system mo. Pinapakita lang dito yung initial tsaka final. Ayos na? Which again, sabi ko, which makes it hard again to use the delta S universe equation, no, or criterion. Kasi nga, Parang hindi siya wala siyang specifics no, na binibigay. Especially sa endothermic. Kasi yung sa nakikita mo lang yung equation para saan? Sa system. Okay? Nakikita ba?
Yes, sir.
Okay, mag-group is okay. Correct.
Tapos mo. Tapos na, sir. Tapos.
Marami pa to.
Tapos.
Hanggang 5:30 pa tayo. May klase sila kay Mango. So, Mr. Rodrigo, baka pwedeng huwag yung hati-hati.
Sige, sir.
Baka kaya mo isang buo na. Mas maganda yun. Kung aabotin tayo 2 hours, kahit 2 videos.
Sige, sir. Sa ba to? Panoorin din.
Okay, so again, we're going to be using the second criterion, the second equation, for us again to determine what? Whether a reaction is spontaneous or not. So we've seen some of the limitations of the first criterion, which is again the delta S universe criterion. Now we're going to be accounting, as the title of this topic says, yung relationship ng entropy, enthalpy, and Gibbs free energy. The delta G system criteria. Okay? Because the delta G system equation accounts change in entropy and change in enthalpy. Okay? As we'll see later. Unahin natin si entropy. Frequently asked questions about entropy. First, how do we define entropy quantitatively? So we're going to be deriving some equations na gagamitin nyo rin sa pag-solve ng problems. Actually, yung sinolve yung problems nun sa heat engines, tsaka refrigerator, tsaka sa car, no? Devices, no? Pwede mong kunin yung mga change in entropy doon. Hindi lang yung Q, hindi lang yung work. The change in entropy can also be accounted. Okay? Kaya nga yung equations lang yung kailangan nating pag-aralan. Kasi yung problems naman, alam nyo na. Diba? So listen carefully. Okay, can you see nakikita ba Mr. Padrigo yung volume? You have a container there with a gas molecule. The dot there is the gas molecule. Nakikita?
Yes, sir. Zoom natin.
Okay. So, we put an imaginary line doon sa gitna ng container. Nakikita yung imaginary line? Yung broken line doon?
Yes, sir.
Then we can subdivide it into V1. Ibig sabihin ng V1 yung mas maliit na volume lang. Yung V2 yung entire volume. Okay? The question now is, find the probability of finding that gas molecule, yung dot, sa V1 lang. How do you get the probability? Tikita. Probability is equal, W is equal to what? Number of desirable outcome divided by number of what? Total outcomes. Ano yung desirable outcome natin? You find the probability ng gas molecule nasa V1 lang daw. Hindi dapat sa V2. Ha? Kuha? So isa lang yung desirable outcome natin. Kailangan yung gas molecule nasaan lang? Nasa V1. Pero tandaan nyo, yung imaginary line, hindi totoo yun, di ba? Hindi totoong boundary yun. Ibig sabihin, si molecule dot na yun, pwedeng gumalaw, di ba? Pupunta saan? Sa right side, tsaka sa left side. Ilan yung total outcomes na pwede? Dalawa. Kasi pwede siyang nasa left side or nasa right side. So what is the probability? 1 over 2. Or basically, V1 over V2. Yung VI is V1 din yun. VF is V2. Parang expansion lang, di ba? From small volume to bigger volume. Somehow, medyo nagkakaroon siguro kayo ng idea. Bakit nire-relate sa expansion? Eh di ba yung mga processes sa devices natin? It's either compression yun or expansion. Sa boiler, sa condenser, sa pump, and sa tawag na? Turbine. Diba? Ano nga yung sa boiler? Expansion or compression? Ano yung sa condenser? Compression. Sa turbine? Compression. Expansion din yun. O, ano yung sa pump? Compression. Diba? So may mga change in volumes tayo doon. Kaya nga na, we're starting to derive an equation for entropy. In terms of what volume? Change. Okay? Now, second question. Find the probability of finding, again, that's that same molecule in V2. Hindi na sa V1, sa V2. Ilan yung desirable outcome mo? Isa lang. Ilan yung total outcome? Isa lang din. Kasi kahit nasa B1 siya, di ba? Nasa B2 pa rin actually siya. Naintindihan? Kahit saan pa siya mag-move, nasa B2 lang talaga siya. Understood? Kaya nga, B2 over B2 equal to 1. Or, desirable outcome is 1. Total outcomes is also 1. Understood? O, kahit ibahin natin yung number of particles, no? With respect to volume tayo, not with respect to the number of particles. Kahit damihan natin yung number of particles, ganun pa rin yung mangyayari. Mas lumalaki yung volume, mas tumataas yung alin, yung probability. Naintindihan? O, sige. Nakikita ba, Mr. Rodrigo? This time, finding N-gas molecule. Sinabi ng N-gas molecule, 2 or more na. Hindi na isa lang. B1 to. Dalawa na yung molecules mo. A and B. First question lagi, apply natin yung first question dito for the two molecules. Kanina isang molecule, ngayon dalawa. Find the probability of finding these two gas molecules sa B1 lang. Ilan yung desirable outcome mo? Isa lang. Ilan yung total outcomes na pwedeng mangyari? Tingnan natin. Isang outcome na yung A and B nasa B1. Tama ba? Isang outcome yung dalawa molecules nandito sa right side na to. Ibang outcome yun. Tama ba? So, ilan yung outcomes? Dalawa. Pwede rin na yung A dito, yung B nandito. Tama? Ilang outcomes na? Tatlo. Pwede rin si B nandito, si A nandito. Ilan lahat ng outcomes? 4. Pero ilan lang yung desirable outcomes? Isa lang. Kuha? So, anong sagot? 1 over 4, di ba? That's 0.25. Okay? Lalagyan natin ng value dito. Sagot dito, 1 over 4 divided by 1. Divided by, that's 1 over 4 is equal to what? 0.25. Kung ito yung i-apply natin, di ba? Pero kung i-apply natin is yung equation na to. Saan ang galing itong equation na to? Galing din yan dito sa BI over BF. Niraise lang natin saan? Sa N. O, i-apply natin itong equation na to. Ano yung BI natin? Equal din yan saan? Sa BI, which is what? Di ba yung BI is kalahati nung BF? Tama ba? Ang BI mo is B1 eh. Ang BF mo is B2. Yung BI or B1 is half nung alin? Nung B2. Kaya nga ano to? 1 over 2. Pero i-erase mo siya saan? Doon sa number ng particles which is equal to 2. So 1 half raised to 2. Ano sagot? 0.25 pa din. Naintindihan? So, dalawa yung ginagamit natin, ito o kaya yung in terms of volume. Naintindihan ba ako? Ngayon, huwag malilito ha. Kasi dito, ilan yung particles dito? Isa lang. Tapos dito, dalawa. Ilan yung sagot kanina dito? 0.5 or 1 half, di ba? Pero ngayon, ano na? 0.25. Bumaba yung probability nung dumami yung particles. Again, hindi natin kinoconsider yung dami ng particles dito. With respect to ano tayo? With volume. Kung babagoyin ba natin yung particles, ano mangyayari dun sa trend ng probability doon sa particles? Tingnan natin ha, tingnan natin yung trend. Pangalawang question, find the probability of, again, finding two gas molecules, saan? Hindi na dito sa B1 lang, kundi sa B2. Yun yung second question natin dito, di ba? Find the probability of that one molecule sa B2. Ano sagot? 1 over 1. Dito naman, I-apply natin sa dalawang particles. Find the probability, no, that these two molecules are in V2. Ilan yung desirable outcome mo? 1. Ilan yung total outcomes mo? 1. Kasi kahit anong mangyari, nandun lang sila saan? Sa V2. Di ba? Kaya nga, ang sagot is what? Yung kanina pa rin, VF over VF or 1 raised to what? Ano sagot dito? Ano ibig sabihin dito? Ibig sabihin, from here to here, nag-increase yung volume, di ba? Kasi dito, find the probability in finding in V1 lang. Dito, find the probability of finding in what? In V2. From V1 to V2. And you see that the probability increase. Kahit isa lang yung particle na i-consider mo, from V1 to V2, ano daw nangyari sa probability? From 0.5 to 1. Probability. Nakuha ba yun? Ngayon, pwede natin i-relate si probability kay entropy. Di ba si entropy may kinalaman kanina kay volume? Kanina? Lumalaki ang volume, ano nangyari sa entropy? Tumataas din. Nice. Ibig sabihin, kung ang volume may kinalaman kay probability, si probability may kinalaman kay entropy. Okay, bibitaw ka. Marami concepts, pero nakukuha niyo naman. I understand, nakukuha niyo naman. Kaya nga, we can say now, we can conclude that, the higher the probability is, the higher also is the entropy. Kasi sabi nyo kanina, mataas ang volume, tumataas ang entropy. Dito pinakita rin na lumalaki yung volume, tumataas yung probability. Kuha? Isang question lang yun, Ang daming in-explain isa. What is the symbol for entropy? S. What is the symbol for probability? W. Having said that, S is what? Proportional to W. Diba? Tataas ang probability, tataas din si entropy. And usually, pag may ganyan, ang ibig sabihin, pag may ganyan, S over W is equal to A constant, di ba? That constant is your what? Is your K, which is what? The nalala ko yan, si 1.38 times 10 to the 23rd, di ba? Joule per atom Kelvin. Ngayon, hindi pa natatapos yan dyan. Sige. Imbes na, anong equation dito? S is equal to what? To K W, di ba? Tawag dito is the, you can say perhaps the Boltzmann equation, but hindi pa tatapos kasi mas appropriate daw kung gagawin ganito. S is equal to K ln of W. Bakit may ln, sir? No? Ano ibig sabihin ng LAN na yan? Kinig kayo. Siguro ngayon nyo lang maririnig to. Iba sa inyo, pero yung iba alam na to. Ano ba ibig sabihin ng LAN? Kinig? Pag sinabing LAN, it has something to do with time. For example, LAN 1, ano sagot? 0. Kasi LAN 1 is actually time present. Pag 1, di ba? LAN 1, 0. Pag Pag 0 ang nakuha mo, ibig sabihin nun, wala pang time na nangyayari, di ba? Na nag-occur. So 0 means present, tama ba? Gawin yung ln 2, doblehin niyo yung 1. Ln 2, anong sagot? Sige. Ln 1, no? Pag sinabi yung ln 1, no? Ln 2, sagot?
0.69.
Positive, di ba? Gawin nyo na yung 1, hatiin nyo. 0.5, ln 0.5. Negative yung lalabas, tama?
Yes.
So, has something to do with time. Pag sinabing ln 1, present. Pag sinabi mong ln 2, dodoblehin mo yung ngayon, ibig sabihin parang tomorrow, di ba? Ano yung magiging sagot? Positive value. Kasi may time na, di ba, na nangyari. Pero kung yesterday, yung 1, hindi pwedeng taasan, bababaan mo, gawin mong 0.5. Ano magiging sagot? Negative. Kasi nga, yesterday. Understand? So again, ln has something to do with time. Eh, sir, anong kinalaman nun dun sa probability? Kasi bago mo makuha mo, bago mo makuha yung probability, it needs time.
Okay.
Bago mangyari yung mga, di ba, yung paglipat-lipat ng mga particles, makukuha mo ba kaagad yun? No, it needs time, di ba? Naintindihan?
Yes, sir.
We'll have another example. Find the probability of another example. Find the probability that this particle A, okay, will collide with another particle. Okay, apply natin itong equation na to. Yung probability, ilan yung, ano yung probability na yung particle A na to magko-collide daw saan? Sa ibang particle. Okay? Isa lang yung outcome natin, di ba? Pero alam natin yung total outcomes, madami. Kasi hindi naman sinabing specific yung particle na i-collide kay A, di ba? Ang sabi, with another particle. Hindi sinabing with particle B. Ibig sabihin, pwedeng lahat ito mag-collide dito. Mag-collide yan dito, dito, dito. Naintindihan? Pero para mag-collide lahat yan, para makuha mo lahat ng outcomes, it needs time. Kung hindi mo i-account yung time, hindi mo makukuha yung alin, yung total outcomes. Hindi mo makukuha yung alin,
Probability.
yung probability. Nag-isip nito, hindi ako ha. Sino nag-isip nito? Si Boltzmann.
Spot.
Diba? Ang galing niya, diba?
Sana kayo.
Ay, dapat fail na. Galing niya. Question? So, you now have this equation, but in thermodynamics, we always account for what? For the change, diba? So, kung delta S tayo, this would be what? Delta S is equal to what? K? Ln? Of what? Tingnan na natin dito. Bayan ko muna. Nakita niyo rito. Kailan? Tingnan niyo. Yung delta S natin is what? SF minus SI or kailan WF, di ba? Minus kailan WI. Now, it can be simplified as kailan WF over WI. Now listen. Di ba si probability may kinalaman kay volume? So yung equation natin kanina ng probability in terms of volume, pwede mo ilagay dito. Meron ka na ngayong equation ng delta S and delta V na pwede mong magamit doon sa mga thermodynamic devices natin. Kasi merong expansion doon, merong compression. Naintindihan ba ako? Sige, bago tayo mag-tigpet, no? Baka hindi magkaklase na. Ituloy na natin. Kung gas expansion yung gusto natin i-consider, hindi na in terms of probability, mas maganda in terms of volume na. Di ba? Gagawin lang natin, from this equation, papalitan lang natin yung mga probability terms. In terms of what? In terms dun sa mga nakuha natin, eto. Meron tayong equation for Wi and W. Mas maganda, ito yung gamitin natin kesa ito, di ba? Bakit mas maganda to? Kasi ito, kahit anong particle. Or rather, kahit anong dami ng particles. Ito para sa isang particle lang. Naintindihan? So, applying that, pasok natin yung equations na na-derive natin kanina. Ito yung magiging sagot. Matatakot na naman kayo. Kung maalala nyo, si WF is just equal to 1 over N. Si WI is just equal to what? VI over VF raised to. Simplifying that, magiging ganito. Furthermore, simplifying that, magiging ganito. Yung N nilagay lang dito. Naintindihan? And furthermore, it can be equated to what? NR ln VF over V. Tandaan nyo 1 over ano to? VI over VF, kaya naging VF over VI. I think, naintindihan naman. Pero ito, bakit NK is equal to NR? I-prove natin later pag lipat natin ng rule kasi baka may magka-class na. Paano gagawin mo? Ipo-pause mo muna, Mr. Kadali. Pause muna and then continue. Pwede ba yun? Pause mo.